In this video, I want to present you some extra difficult examples. They are actually some examples that can be solved quickly if one recognizes maybe what there is to do. You see it here. So the first one, it's actually a polynomial squared. The second one, it's an algebraic fraction. And the third one, it's something that contains logarithms and exponential. Let's start from the first one. So an obvious way of doing it, and that's what I'm going to do here, it's to expand this term. So I'm going to have that this is going to be the integral of x to the power of 4 plus 1 plus the double product, so 2 times x to the power of 2. I could also solve it in a different way, but in this case it's actually very easy to do it like that. Then I will separate it into the first integral, that it's x to the power of 4 in dx, plus the integral of 1 times dx, so dx, plus the integral of 2x squared, so I bring out the 2, it's a constant, times the integral of x squared in dx. And therefore here I can just solve this. The antiderivative of x to the power of 4, it's x to the power of 5 divided by 5, plus the integral of 1, it's x. The integral of x squared, it's actually x to the power of 3 divided by 3, plus a constant, where the constant belongs to r. And that's it. Let's take the second one. This looks a little bit more complicated. But in reality, this algebraic fraction can be expressed in singular pieces. So if I have here the integral of 1 plus the second plus the third term divided by x, I can just divide each term by x. So I'm going to have actually 3x squared divided by x plus 2x divided by x plus 1 divided by x, and everything is in dx. So I'm going to have that the integral is in reality 3 integrals. So I'm going to have the integral of 3x plus, let me rewrite these pieces, right? So this one simplifies with this, x simplifies with that, so I have plus 2 plus 1 over x in dx. And therefore, also in this case, I can separate the 3 integrals. So I'm going to have 3 times the integral in x plus 2 times the integral in dx. Sorry, I always forget dx. And then plus the integral in 1 over x in dx. And therefore, this is going to give me 3 times the integral of x, it's x squared divided by 2, plus 2 times the integral of 1 dx, it's actually x, plus a special one. This is the special power, because it's a power of -1, and therefore I remember that it's actually the natural logarithm with the absolute value of x. And then I have my usual constant c, where c is belonging to r. Third one contains logarithm properties. So in order to solve this, I need to know that the natural logarithm and the natural exponent, they are actually the inverse function of each other. And therefore, this expression here actually simplifies, because these two functions, they kind of, if you want to, cancel out, although it's not a cancellation because they are inverse function. So this integral, that it's an integral in another variable, t, it's 2t minus 1 in dt. Don't be scared if the variable changes, that can happen, okay? It's just a name, it's just a notation. So this is actually the integral of what? Well, I can take out the constant here and therefore have the integral of t in dt, and then minus the integral of 1 times dt. And therefore the result is going to be 2 times t squared divided by 2 minus the integral of 1, it's t. So that's it. So I'm going to have plus a certain constant, where the constant belongs to the real numbers. And I'm kind of done here, although I can simplify, right? So I'm going to have t squared minus t plus c. we'll see it's real.